And now that we've done this, we can run a few simple queries on it. So for example, we can check. We have a bunch of nodes. We can check to see whether a particular edge exists. So we say, does this network have edge 2,9? And it says false, because we don't have edge 2,9. There's no, between 2 and 9, there's no edge. We can check and see whether node 2 is in our, whether a particular node is present in our network. Right? If it says node 2 is there, it says true. And if I do node 10, it says false, because we don't have node 10 in the network. I could check and see how many edges are there in the network. We have 11 edges, so that's the count of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So 11 edges. Then we can check to see whether how many nodes are there. The simple queries that you might want to do in a graph. I mean, we know because we set it up like this, but we might be reading the data from somewhere else, and we want to find out how complex our graph is, right? So the number of nodes is 9 here. Then we want to set up the order of the node, which is really, it tells you how many edges are there in it, I guess, how many nodes are there. And then finally we have the length of the simple network, which is also the number of nodes in the network. So that's what a very simple stuff to figure out essentially how complex our network is. Of course, we want to do more than that. We want to iterate over the network. So let's just see what are the various iterators we can use on this. So we can iterate over the nodes, and that gives us list of nodes. So we call the nodes iterator, the function nodes iterator, and iterates over the nodes, and we get our different nodes and that stuff. We can iterate over the adjacency list of the node. So what this tells us is that node 1 is adjacent to 2, 3, and 9. Node 2 is adjacent to 1, 3, and 7. So this is kind of useful when you're going through a node and you want to find out, for example, let's say you've got you want to see whether 2 is well, I guess you could go to 2 and look at it, but what nodes are adjacent to 2, you can just use this to figure this out, the iterator to figure that out. Or if you want to count the number of nodes that have 3 friends, for example, right? 3 adjacent nodes, you can use this, iterate over this stuff, and then count the number of adjacent nodes in this in the thing. You can iterate over the edges. So this gives us the edges, a listing of the edges. We have 11 edges, and you get edges are between 2 pairs of nodes. So we get a pair of nodes for each edge in this network of ours. And you can iterate over the degrees, and what this gives us is that for each node it tells us the degree. The node degree is the number of edges that come out of a node. So for example, we have node 1 has a degree of 3, and node 5 has 2, and node 6 has 1. So if we go back here and look at node 1, it has 3 edges from 1 to 9, 1 to 2, and 1 to 3. We can make that a little bit clearer. If I run this again, yeah, 1 to 9, 1 to 2, and 1 to 3. Whereas node 6 has only 1 edge that goes from 6 to 5. And node 5 has 2, 5 to 4, and 5 to 6. So the degree really tells you how many edges are coming out of a particular node. And that's again very useful when you want to figure out, for example, which node is the best connected. Who on Facebook has the largest number of friends? You know, that would be the kind of question you want to ask, and who has the least number of friends. So that's the basics of what we can do with nodes. And finally, there are many different kind of graphs. We are only going to look mostly at 1 or 2 types here, but you can get a undirected simple graph, which is the kind we've seen so far. A directed simple graph that will have arrows that tell you that you can go from node 1 to 2, but maybe not from 2 to 1. You can go to undirected graphs with parallel edges. So you have an edge going from 1 to 2 and another edge coming from 2 to 1. So each edge is different. And you can have a directed graph with parallel edges. That is an edge going from 1 to 2 and another edge coming from 2 to 1. So these are kind of graphs that we have over here. We're going to be using essentially today only simple graphs, and that's pretty much it. Okay, so we don't really have anything else there. So that's the basics of networks, and when we come back, we're going to look at some more. Before we finish, actually, sorry, we should also look at this. The other last kind of thing that you might want to ask, simple thing you might want to ask is, what is the shortest path in a network? So between 2 nodes. So we want to go from 6 to 8, and this tells us that the shortest path goes 6 to 5 to 4 to 9 to 8, and we can check that out here. 6 to 5 to 4 to 9 to 8. That's the shortest path. We could also go 6, 5, 4, 3, 1, 9, 8. It's longer. Or 3, 1, 6, 5, 4, 3, 1, 2, 7, 8, which is even longer. So this tells us which is the shortest path in the network. And it can also tell us what the length of the shortest path is. So if you use the function shortest path length, then that tells us that the shortest path length is 4. So when we come back, we're going to look at a little bit more complicated a few more complicated examples, and then try to understand how we can use network X to analyze a graph.